Before inspiration, intra-alveolar pressure is equal to atmospheric pressure. There is no pressure gradient, so there is no airflow. As the thoracic cavity enlarges, the lungs are forced to expand and fill the larger thoracic cavity. As the lungs enlarge, the intra-alveolar pressure drops because the same number of air molecules now occupy a larger volume, so pressure decreases. The intra-alveolar pressure is now less than atmospheric pressure, a pressure gradient has been established and air flows into the lungs. As a result of the expansion of the thorax, the intrapleural pressure decreases. This increases the transmural pressure gradient, which ensures the lungs are stretched to fill the expanded thoracic cavity. In summary, the larger the thoracic cavity, the greater the drop in intra-alveolar pressure, which leads to a larger pressure gradient, which leads to more airflow into the lungs. Air will flow until the intra-alveolar pressure equalizes with the atmospheric pressure and no pressure gradient remains. During expiration, the reduction in size of the lungs increases the intra-alveolar pressure. The pressure gradient established is the reverse of that for inspiration, and air flows out of the lungs until a pressure equilibrium between the lungs and atmosphere is reached, and the pressure gradient no longer exists. Contraction of the expiratory muscles further reduces the volume of the thoracic cavity and the volume of the lungs. The intra-alveolar pressure increases further, and the pressure gradient to the atmosphere is greater than passive expiration, so the lungs are emptied more completely. This diagram summarizes the relationship between the intra-alveolar pressure and the intrapleural pressure during the breathing cycle. During inspiration, intra-alveolar pressure is less than atmospheric pressure. During expiration, intra-alveolar pressure is greater than atmospheric pressure. At the end of both inspiration and expiration, intra-alveolar pressure is equal to atmospheric pressure because the alveoli are in direct communication with the atmosphere and air continues to flow down its pressure gradient until the two pressures equilibrate. Throughout the respiratory cycle, intrapleural pressure is less than intra-alveolar pressure. Thus, a transmural pressure gradient always exists, and the lung is always stretched to the same degree, even during expiration.